Alright, here we go with homework help for homework number 2. So graphing rational functions have lots of steps to it, but if you practice it, which you all doing, then you'll get good at it, which would be awesome. Okay, so sketch the graph of the following equation. So first we want to see if we can simplify anything. And we already did one in class, I believe. So we're going to jump down to number 3. Okay, so it looks like it's already been simplified. Does anything factor out? Not that I can see. So it looks like it's already simplified, right? It's already in the factored form. Can't factor anything. Okay. So next, since that's already simplified, then does anything... none. There are no discontinuities or no holes. So none, no holes. There's gonna be no holes in this graph. That's donut holes. Nice. Okay, so then for our x-intercept and y-intercept, there we go. So x-intercept, you basically set the top equal to 0. So we're going to go ahead and take the negative 4x plus 1 and set it equal to 0. The reason why is you multiply the x minus 2 to 0, and so it becomes... So then we're going to minus 1 to both sides, so we get negative 4x is equal to negative 1. And then we divide by negative 4. Divide by negative 4. And so we get an x-intercept at positive 1/4. So that's going to be right about there on our graph at 1/4. Okay, then the y-intercept, you set all the x's equal to 0. So you go y is equal to negative 4x plus 1 all over x minus 2. That's the simplified function there. And wherever you see an x, you're going to put a 0. So it's there and there. So the negative 4 goes away, the other x on the bottom goes away, so we're just left with negative 1/2. And so that's our y-intercept, so we go down negative 1/2. Wow, those are really close together, aren't they? Yes, they are. Okay, to find the vertical asymptote, we set the bottom equal to 0. So we do x minus 2 equal to 0. We're solving for x, so we're going to add 2 to both sides and just get x equals positive 2. So that's the vertical asymptote. So that's 1, 2. So right about there. Go ahead and do a dashed line there for our vertical asymptote. For our horizontal asymptote, we look at the power and set the first power, x to the first power. Then we're just going to look at the leading coefficients in front. So negative 4 over 1. So the horizontal asymptote is y equals negative 4 over 1, or just negative 4. Okay. So then we're going to go down 1, 2, 3, 4. And so at negative 4 is our horizontal asymptote, right? Horizontal asymptote. Looking good so far. Okay, before we can find the domain and the sign chart, we're going to finish our graph. And so we always let the x-intercept and y-intercept be your guide. Always let the intercepts be your guide. Right? So taking a look at where our asymptotes are, it looks like we're going to end where our x-intercept, y-intercept is. Looks like our graph is going to come along here. Let's do it in a different color there. So it's going to come along our asymptote, cut through our x-intercept, our y-intercept, x-intercept, and follow along our asymptote there without crossing the asymptote. And then, since this looks like a pretty simple rational function, it'd also stand to believe that we would do it diagonal across from it. Now, if you're not sure if that's true or not, then you could do you could actually do a test point, right? Do a test point. And so a test point would be like choosing an x value over here. So maybe like not 1, not 2, but maybe like 3 or 4 would work. That would help us to know if our graph is above or if it's below using a test point. So why don't we go ahead and use x equals 4. So we're going to go back to our equation, which was y equals negative 4x plus 1 all over x minus 2. And then we're going to plug in x equals 4 everywhere we see an x. So we're going to plug in a 4 right here in parentheses and a 4 right here. And that's going to be negative 16 plus 1 is negative 15. All divided by 4 minus 2 is 2. And so that's going to be what? Negative 7.5. Nice. So over 4, down 1, 2, 3, 4, 5, 6, 7.5. So that test point helps us to see that our graph does fall below there, in the bottom right quadrant of those asymptotes. Cool. Awesome. So there is our graph. So we didn't have any holes. We did have asymptotes. And so our asymptotes are going to determine our domain. And so we're going to go from negative infinity, carry along x values, x values, x values, x values, boom. So our vertical asymptote at 2, right, is going to make it where it's undefined, where it's going to make it a problem. So we're going to go from, our domain is going to be from negative infinity to 2, in union with 2 to positive infinity. So there's our domain. Then our sign chart is going to use our vertical asymptote at x equals 2, and wherever we're above and below. So this actually might be trickier than I taught in class. The reason why is over here we have a negative symbol because the graph is below. The graph is below the x-axis here. And so we would put a negative symbol, right? Put a negative symbol. Okay. Then right between here and here it does become positive. And then down here it's negative. So it goes, right? So it goes negative, then positive, then negative. Go, rainbow. So we're going to go negative, then positive. The graph's above the x-axis, and then negative. Cool. So we actually need a line chart. We actually need another bar. What? Yeah. Actually going to come over to here, I think. So here is where it changes. Here's a sign change. But also where it crosses right here is a sign change. And that wasn't that 1/4? X equals 1/4? Yeah, so x equals 1/4, the x-intercept. So we have the x-intercept is where a sign change happens. And then, so that's here. And so that's at x equals, that's 1/4. And then also the vertical asymptote, the VA, is also where a sign changes. So it's going to go below the x-axis, then above the x-axis, then below the x-axis. So there's our sign chart, minus, plus, minus, with 1/4 and 2 being those key numbers there. So that's how you do number 3. And then we'll do like maybe a harder one here. Let's see. Ooh, yeah, number 5. Pretty good. Number 7. Ooh, number 8. Let's try number 5. That looks like a pretty nice one. Just double checking this real fast. Boom. Thanks. 5 now. So again, we want it in simplest form. And so give it a try first. Nope, nope. Don't wait for me. You try it. What are factors of 21? Yeah, did you say 7 and 3? Good. So we have 7 and 3. The negative symbol goes with the larger number, so negative 7 and a 3. Because negative 7 and a positive 3 is negative 4. Good. Okay. So now we have y equals x minus 7 all over x plus 3 times x minus 7. Whoa. And so since the top and bottom are going to cancel there, so we was going to have a VA, a vertical asymptote, at negative 3 and at positive 7. But since the, so there's a bad looking arrow. Wow. There we go. So since the x minus 7's cancel, they become the whole. And what's another word for whole? O-N-U-T, donut hole. So donut hole. So discontinuity is another word for whole. So we are going to have a whole at x minus 7. Set it equal to 0. Add 7 to both sides. So we are going to have a whole at x equals 7. It's going to be our whole. Okay. Now the other one, which is our x plus 3, will be in fact the vertical asymptote. So we are going to do the bottom equal to 0. Minus 3 to both sides. So we do get x equals negative 3 for our vertical asymptote. 1, 2, 3. Do a dashed line there. Won't judge you on your art if you don't judge me on mine. Horizontal asymptote. It looks R1 is less than 2. So that means we'll just do the horizontal asymptote of y equals 0. So that means that we're going to go along the x-axis like so and do our other asymptote. Nice. Okay, so now to do the domain, you need the graph first, and to get the graph first, you do the x-intercept and y-intercept. So x-intercept, you take the simplest form, and y-intercept, you take the simplest form, which it turns out x minus 7 canceled, so that actually just became a 1. A 1 over x plus 3 is all that reduced to, 1 over x plus 3. Nice. So to find the y-intercept, you set x equal to 0. So you get 1 over 3, so just 1/3. So we go y-intercept at 1/3 there. There we go. Really close to the x-axis, but it is at 1/3. Then the x-intercept, you set the top equal to 0. And since the top is just 1, well, that doesn't make sense because 0 does not equal 1. So for the x-intercept, then, you just say none. X-intercept, you say none. For the y-intercept, you say 1/3. Cool. You getting it? Hope you're getting it. So pause this at any time or slow down, speed it up, just to try to learn yourself using these videos. Really just trying yourself is the best way. And then looking at the video. Okay, so domain. First we've got to graph it. Well, looks like we have a y-intercept here at 1/3 on the y-axis. So then our graph would go along the asymptote, come through the y-intercept and go along that other asymptote, which we could make red so we can distinguish between the line and the asymptote. Nice. Cool. Okay, so then we're hoping that it's probably going to be diagonal. We can do a test point there. This time I'm actually going to use my graphing calculator to see if we did it right. So hopefully it should be diagonal opposite is our graph there. But let's go ahead and plug it in and see. Calculator, get it out, and go to y equals. There it is. Go to y equals. We'll clear that. We'll type in. Make sure to do parentheses now. Lots of parentheses, else you may get it wrong. So x minus 7. Let's do the full form there before we cancel stuff out. So otherwise we wouldn't see our hole there. Oh, we forgot to graph our hole. We forgot to graph our hole. Where's our hole at? Oh. So we go 1, 2, 3, 4, 5, 6, 7. And so we're going to put a hole right there. It's kind of hard to see it because that graph is so close to the x-axis, but there should be a hole right there. Cool. So here it is. So we're going to go and type in now x squared minus 4x. There it is. And then minus 21. Making sure to use that correct subtraction symbol there. We're going to graph it, and bam, there it is. Boom, we have an asymptote there. Add negative 3, and then along the x-axis. Now let's see if our hole is there. So, oh, there's the 1/3 for our y-intercept. Boom, 0.3333 is 1/3. And then x equals 7 is where we should have a hole. At x equals 7 exactly. There we go. We should have a hole there. Ooh, can't see it, so let's go second calc. Let's go to value. Let's type in x equals 7. Then we push enter. Boom! Y equals nothing. There's a hole there. Nice. So our hole has to be counted in our domain, right? Our hole has to be counted in our domain. And so when we're doing our domain, we got to do, what should we call it? We got to do the vertical asymptote, right? Vertical and the hole too. So we're going to go from negative infinity, right. So negative infinity to our asymptote, then skip over it, and then go from our asymptote to the whole, skip over it, and then to infinity. So x value is only for a domain. So did you do it? Go ahead and give it a try. Try it first yourself. Let's see if you got it right. Okay, pause me. So negative infinity to negative 3 is the vertical asymptote, yep. In union with negative 3 to the whole, which is at x equals 7. Ooh, erase, you little eraser. Why is it erasing? Ooh, it's not erasing. There we go. Okay, there we go. So negative 3 to 7. You little put them there. So, what the, you little, why'd you, okay. Okay, there we go. Whoa, that's a thick pen. Okay, so we have, that's it, 7. There we go. Wow, it doesn't like. There you go. Okay, negative 3 to 7. In union with 7 to the right forever to positive infinity. So there's our domain. Now, looking at our sign chart there, looking at our sign charts, we need to look where it changes. So you could draw on your graph that there's a negative symbol because it's negative below the x-axis. Ooh, then it's positive, and still positive after the whole. So up to you if you want to include the whole there or not. We could if you want to at 7 and at negative 3. So it'd be negative, then it'd be positive, and then still positive. Or if you just put negative, positive, I'd still give it to you. Cool. All right, so there's how we do number 5. So try the other ones, 2, 3, and whatever ones we haven't done yet. What, 2, 4, 6, 7, 8? Yeah, so get those finished up for next time. Thanks for watching. Yo. So there's our answer to help you on number 5. Thanks for watching. Watch again. Peace out.